We are going to look at geometrically how do we sum, subtract, and multiply vectors by scalars. Let's begin with the sum, and this is something that I'm sure is well known to you. Let's say we have a vector going, let's just call it v, and we want to sum a vector, let's say w. So the first thing I'm going to do is to position the vector w so that its starting point is the end point of v. So over here, this is my vector w. So the vector sum determined by them is going to be a new vector that starts where v starts and ends where w ends. So this is my vector v plus w. There is another way of achieving this. We could, here I have a copy of my vector w. We could position it at the starting at the same point as v starts, and then we can complete a parallelogram with having one of the sides v and the other w. So in this case, I'm only missing one of my parallelogram sides over here, representing v as well. So if I construct such a parallelogram, the vector sum is the diagonal of the parallelogram. If what I wish to do is to subtract vectors, let's say I have my vector, let's call it v again, and I want to do v minus w. And then this is going to be the same as doing v plus the vector minus w, so the negative of w. So whatever my w is, let's say this is w, then I'm going to consider another vector that is exactly like w but with the arrow pointing in the opposite direction. So that would be how it looks like, minus w. And this is the vector I need to sum to v. So with the parallelogram rule, I will end up with, choose another color. It will go here. This will be v minus w. And notice that if I could have also obtained this same vector by doing v plus w, that gives me here a parallelogram. Let me just make sure that I'm making this big enough. No, I'm not. Look like that. So that will be my parallelogram. So if I wanted to sum, I would take the diagonal of the parallelogram, the main diagonal, let's say. But because I want to find the difference, then I need to consider this other diagonal instead. So this is another way of achieving v minus w. So we talk about the sum, also about the subtraction. And the last thing I want to mention is the multiplication by a scalar. Let's say we begin with a vector a. That's my vector a over here. And I would like to multiply it by a scalar. So the result ka, let's say that k is not 0, it's going to be parallel to a. Its magnitude is going to depend on the absolute value of k, and it will point in the same direction of a if k is positive, and in the opposite one if k is negative. So for instance, let's say we consider k equals 2. So in this case, our new vector over here is gonna be this one, parallel to A, pointing in the same direction, magnitude 2 times the magnitude of A. If we consider, let's say, for instance, k equals -3, then the new vector, I'm going to begin by making it parallel to A. That's parallel. The magnitude is 3 times the magnitude of A, but now the arrow is pointing in the opposite direction. So this is -3 times the vector A.